Welcome back to eCoreAcademy, students. My name is Anita Raj, and I am one of the co-founders and teachers here, along with my younger brother, AJ Raj. Today, as you can see, I have a new Algebra 2 lesson prepared for all of you, and it's a continuation of the quadratics unit we have been doing in Algebra 2. Today's lesson is going to be part 2 of our mini-series on modeling with quadratic functions. Again, part 2. Part 1 was my last video in which I went over some key concepts with all of you. I went over a key idea where I drew out different parts of that definition, and then we did a practice problem together where I showed you how to do it by hand and then with the calculator. In this practice problem, we had 3 points, and then we had to give the standard form, the quadratic function in standard form of a parabola that passed through all 3 of those points. That's a recap of part 1. If you haven't watched that yet, I'll put the link in the description box so you can go and watch that first before transitioning into part 2. In this video, I'm going to be giving you a application as in a real world problem, and it's going to be a word problem. We're going to be using the Texas Instrument calculator that I use in almost every one of my videos to be solving this problem. In our next section, after modeling with quadratic functions, we're going directly into quadratic applications. So this is going to prepare you for what real life scenarios you'll be seeing in those problems, and then it's also going to be helping you get used to using the Texas Instrument calculator. Okay, before I even get into the video plan for today, I would really appreciate it if you paused and liked the video to support AJ and myself as content creators here at eCoreAcademy. Also subscribe so you can join our student community. Hit the post notification bell so you're notified of our latest posts, and don't feel afraid to drop a comment down below. We love to hear what you think, and we love to hear your advice, suggestions, questions, etc. Lastly, use our socials in the description box to share eCoreAcademy with all your family and friends who could possibly benefit from it. Okay, let's get right into the video. On this first slide is just going to be me talking about the actual problem. And then after the problem, we have 4 parts that we're going to solve. So 4 questions that accompany this problem and the information I'm going to be showing you. We have part A. Then we have part B and C. I combine these together as a paired question, but realistically on an assessment, you might see them as 2 separate questions. For this sake, we're learning how to approach these problems. So I thought it'd be easier if I showed you them together as a combo question. And then we have part D, which is our challenge question. So let's get into the application itself. So here's some information that is important for you to know. Here's the actual word problem I came up with. So this table that you see right here on the screen, this table shows a meteorologist's predicted temperatures for a November day in Voorhees, New Jersey, with x equals 0 as midnight. So let's break all this information down. This table, so the table on the screen right here, on the left-hand side, you can see time as the title, and then you see these times during the day, 8 a.m., 10 a.m., 2 p.m., 6 p.m. written. And then right next to it, on the right-hand side, you see the predicted temperature in degrees Fahrenheit. And then you see these temperatures ranging from 45 degrees all the way up to 75 degrees. And these are all predicted temperatures. These correspond to the time. So at 8 a.m., the given temperature is predicted to be 45 degrees. At 2 p.m., the given predicted temperature is going to be 71 degrees. So a meteorologist is predicting these temperatures. If you don't know what a meteorologist is, simply a scientist who studies weather and makes predictions. So the weather forecasts you see, they study the atmosphere and how the atmosphere is, the state of the atmosphere at a given time of Earth. And then they come up with predictions of what our weather will look like for a day, a week, a month, etc. So that's what a meteorologist is. Again, the time is your x variable, your x coordinate, which is your independent variable. Time doesn't depend on anything. For it to be 8 a.m., you don't need to depend on another variable. However, predicted temperature, which is our y variable, our y coordinate, that is a dependent variable. It's depending on the time. So depending on the time, you will have a specific temperature. So at 10 a.m., the given temperature will be 67. 67 depends on the time. The temperature 67 depends on that time of day. So it's just a random November day in a place called Voorhees, New Jersey. Again, that part is all made up. I didn't actually take weather statistics. That part's made up. And probably one of the most important parts of this word problem is the fact that I wrote x equals 0 as midnight. So if you remember, I think we did it in our 3 variable systems where I walked you through a word problem or something like that where we were using the calculator. When we assign a time as 0, every hour that comes after that counts as like 1 hour away from that. So if we say midnight is 0, well, midnight is 12 p.m. It's in the middle of the night. Therefore, if 12 p.m. is 0, and we're going to put that into a calculator, into our table, and the temperature was 70 degrees at midnight, we would put the coordinate 0, 70, because instead of writing 12, we're writing 0, because that is hour 0. That is our first hour. So if midnight is 0, then 1 a.m. in the morning would be 1, because it's 1 hour away from midnight. Or if we're talking about 1 p.m., well, 1 p.m. is 13 hours away from midnight, so we wouldn't put 1 in as the x-coordinate. We'd be putting 13 in. So that's what x equals 0 as midnight is. Make sure you understand that concept. I've gone over it a few times before, but you're really going to have to understand that concept because we input values into the TI calculator. You have to be able to do that in mental math and be able to assign different values to these hours that you've been given. So make sure you understand that. So that is the application. On the next slide, we are going to be approaching part A, and I'm going to be showing you the question and then the solution. Okay, we're on the next slide. I have the calculator right above me. I'll pull it out to this side of the screen right over the work every time I go over a step. The problem is at the top, and then right underneath it, I have the solution, like as in the generic steps of the solution, but I'll be showing you the specific steps using the calculator, and I'll be explaining it. If you have a TI calculator, please pull it out and follow along. If you'd rather listen and go back and use your calculator and try to solve this problem, feel free to do that as well. Just make sure you're doing whatever you can so you understand these concepts that I'll be showing you. Okay, part A. So the problem is I'm asking you to use the TI to find a quadratic model for this data, then save it in Y1. What does that mean? So if you refer back to the table I showed you on the last slide. I can't put it on every single slide because it's a pretty large table and I have limited space, but refer back to that and you'll see that the 6 hours I gave you, 8 a.m., 10 a.m., 12 p.m., 2 p.m., 4 p.m., and 6 p.m., those are 6 data points, and their corresponding y-coordinate are the temperatures I've given you on the right-hand side of the table. So those are your data points. You're going to be putting them in your table, then plotting them on a scatter plot, and then you're going to be finding a predictive quadratic model, as in your quadratic regression, if you remember from our linear regressions. Same applies here. Then you're going to be finding a quadratic model that best represents this data set, so these 6 points, and then you're going to save it in your y1. So your first, and you go to your y equals, your first equation should be that predictive model. So how exactly are we going to find the quadratic equation in standard form that best fits these 6 data points? So this is what we're going to do, and it's all written in the solution. First, we're going to hit stat, then 1 for edit, and then we're going to enter our points. So let me pull my calculator out from behind me so I can show you exactly how to do this. So before we start, I would highly suggest you clear your calculator, so you're starting with a fresh plate. Remember second, then mem, which is this plus sign, 7, and then 1, and then 2, and your calculator should be cleared. So I'll give you a second to do that. Okay, so let's go into the problem. As you can see, the steps appear on the right-hand side of the calculator, so you can follow along with the buttons and steps I'm doing and the buttons I'm pressing. Okay, so first we want to go to stat, like I just said, and then we want to hit 1 for edit, and then we have our L1, L2, etc. table. Remember, L1 your x coordinates and L2 is your y coordinates. In this case, L1 will be our hours as in time, and then L2 will be our temperature at that given time. So the first time I have is at 8 a.m., the temperature is 45 degrees. Well, we have to think of it this way. Since midnight is 0, how many hours away from midnight is 8 a.m.? 8 a.m. is 8 hours away from midnight, so we would just write 8 as our x-coordinate, and then the corresponding y value, which is our predicted temperature, is 45. So I just typed that in. That one's pretty straightforward. Our next one is 10 a.m. 10 a.m. is 10 hours away from midnight, so our L1, our x-coordinate will be 10. Temperature at this time is 67. Remember, I'm just referring to the table I showed you on that last slide. I'm not pulling this off the top of my head. 12 p.m. is the next time I have. 12 p.m. is 12 hours away from 12 a.m., which is midnight. So again, we would just write 12. And then our L2 would be the corresponding time. It's 70 degrees at noon, so 70. Our next one is 2 p.m. 2 p.m. is 14 hours away from midnight. And because it's 14 hours away, we're not writing 2 in our L1, we're writing 14 in our L1. So 14, and then the corresponding temperature at this time is 71 degrees. And then our next one is 4 p.m. 4 p.m. is 16 hours away from midnight, so I'm writing 16, not 4. And then the temperature at this time is 75. Next, we have, let me go back to the table. Next, we have our last data point, which is 6 p.m. 6 p.m. is 18 hours away from midnight, so I'm going to type 18 in. And then I am going to type the corresponding temperature at that time, and it's 69 degrees. Okay, now that we have all our data points in, let's move on to step 2 to see what we're going to be doing with those data points. I'm going to move my calculator behind me, and we'll read step 2. We're going to our y equals next, then we're going to turn plot 1 on, graph, and then adjust the window accordingly so we can see all 6 points. So let's do that on the calculator. We're going to y equals, which is right here. Then we are going to hit the up arrow to go to plot 1. And plot 1 enables your scatter plot. If you don't enable that, you won't be able to see the 6 points graphed. So you need to enable plot 1. When your cursor is blinking on plot 1, just hit enter and you should be good to go. And then we're just going to hit graph. As you can see, this is just your average, your standard grid. So it's just -10 by 10 and -10 by 10. Our points are much higher than that, so we need to adjust the viewing screen accordingly. To do that, we go to Window. We can manipulate Xmin, Xmax, Ymin, and Ymax accordingly. So the highest temperature we have on this list is 75 degrees. So our Ymax, we should probably crank it up all the way to 80. The latest time we have is 6 p.m., which is 18. So I'm just going to, for good measure, I'm just going to change this to 30 so that we can see all the points. Now that these have been changed, we really don't have to mess with the Xmin or the Ymin. If you want to, you can, but I didn't. And here you can see all 6 points graphed. So now that we have all the points graphed, we adjusted the window so we can see all of them. Let's move on to step number 3. Next, we're going to hit Stat. Then we're going to the Calc menu and then hit 5 for quadratic regression. Let's do that right now. So we are going to Stat, which is right here. Hit the right arrow to go to the Calc menu and then hit 5 for quadratic regression, as you can see right here. And now we're on this new screen. So let's read the 4th and final step. Scroll to store regular equation, then press the vars key, scroll to the y-vars menu, and then hit calculate. So let's do that right now. We're going to scroll down 1, 2, 3 to store, and then we are going to hit the vars key, which is right here. Hit right to go to the y-vars menu, hit 1 for function, and then 1 again for y1. Then you're going to hit the down arrow so your cursor is blinking on calculate, and then you just hit enter. And now you have been given the predictive model, as in the quadratic regression. And as you can see, our A value is about -0.607. The answer is right below the calculator in green at the bottom of the screen. I've copied it down already. B is about 17.857. I'm rounding to the nearest thousandth. And then C is -56.286. So that's how we got that. Part A has been solved, so to store that in your Y1, it's already been stored in your Y1, so don't mess with this. Leave it alone. So part A is done. We found the predictive model that represents this all 6 data points. So let's go to the next slide where we're going to be solving B and C in tandem. I've switched to the next slide. We're going to be solving parts B and C together. I'll show you where the part B is and the part C is and how I've joined them together. So let's read the problem the next question I'm asking you. Using the model we just found, as in the quadratic the predictive quadratic regression that I have stored in our Y1. Use the model to find the high temperature of the day. So when will the temperature peak? When will it be at its highest? What is the highest Y value of this function? And then when it occurs. So what is the corresponding X value, as in what is the hour that this occurs? So that is the question I'm asking. So the reason I'm calling it parts B and C is that on a assessment, you might see the question, what is the high temperature as part B? And then when does it occur as part C? So you might be asked to separate that Y coordinate and the X coordinate, as in you might be asked to separate the temperature and then the time when that temperature occurs into question B and then question C. I'm combining it for our sake, just for time, and so that it's probably easier for you to understand it this way if I explain it this way. Okay, so here is the solution. How are we going to solve that? How are we going to find the highest temperature, so like the topmost, the peak of the day, and then the time when it occurs? So this is what we're going to do. First step, I have the four steps listed under solution, and then the answer at the very bottom of the screen. So first step, we're going to hit second, then trace, and then 4 for maximum. So let me show you what I mean. First, let's go to our graph. So I'm going to hit graph so that you can see this parabola graph through the 6 points. So we're asking for the high temperature of the day. So we're asking what is the largest Y value. In this case, this is our vertex right up here in this parabola. Our vertex is the maximum. Therefore, what do you think we're trying to find? Just think about it for a second. We're trying to find the vertex because the vertex has the highest Y value, which is the highest temperature of the day. So in other words, we're pretty much just trying to find what the vertex is. So let's do that. So like I said here, we're going to hit second and then trace and then 4 for maximum. So hit second, which is right here. Trace is right between zoom and graph in that top row of buttons. And then we're going to just hit 4 because 4 says maximum. So maximum is your vertex in this case because it's like the very top of the parabola. If we had a parabola that was no, it was the very top of the parabola, exactly. So hit 4 for maximum. And let's go to the next step. Let's actually do these 3 steps together. You're going to scroll to the left. So if you see here, you're going to scroll to the left of the center, and then you are going to hit enter. So let's actually do that in isolation so that you're not confused. So if you see right now, you can see this cursor blinking on your screen. So you know the center of the parabola is the vertex, is your axis of symmetry. So what you want to do purposefully is you want to scroll to the left. So you want to use the left arrow, scroll to where you think is going to be perfectly left of the center. So here, right now, I might scroll a little bit more to the left, and I might be happy with that point. And then after that, you just hit enter. And you see this line that's graphed. You can't see it very well on my calculator, but you'll be able to see it on yours. So let's go to the next step. The next step, putting this together, will probably make more sense to you. You want to scroll to the right of center and hit enter. So you're going to do the exact same thing, but instead you're going to use the right arrow, and then you're just going to hit the right arrow over and over again until you go to a place that you think is perfectly symmetrical, so perfectly on the right side, complementing the left side that you just graphed, and then just hit enter when you're satisfied, and you'll see another line graphed through that point, another vertical line. And then finally, you want to scroll to where you think the center is, where you think the axis of symmetry and the vertex is, and then you hit enter one last time. So it should say guess on your screen. So I'm going to scroll left because I need to go left to get to the center. And then wherever I personally think the vertex is, the calculator in these series of steps is pretty much just asking me, where do you think the vertex is? And then it'll make its prediction. So I think the vertex is right there. So I'm going to hit enter one last time. And then I'm actually given the vertex, the calculator computes it. So this is going to be your final answer. So it says X is about 14.706, and then Y is about 75.017. I rounded it to the nearest thousandth again. So what does this coordinate pair actually mean? Well, this pair means that, remember, your Y value is your high temperature, your X value is when this occurs. So if we look at our Y value, 75.017, that is pretty much just telling us the high is about 75.017 degrees Fahrenheit. That is the high for the day. 14.706 is supposed to represent the time. However, we're not going to write it as the hour 14. That doesn't make sense. We have to change it back into the hours we usually read. So in order to do that, you would subtract 12 from 14 for that 12 hours, for those 12 hours, and then you see that's 2 p.m. 2 p.m. is 14 hours away from midnight. So 2 p.m., and then you would get, and then in Algebra 2, especially in Honors Algebra 2, you have to give the closest approximation, so all the way to the minute. So I wrote 42 minutes, so 2:42 p.m. would be the near exact time when it reaches the high for the day. And you might understand how I got the 2 o'clock part, but you might not understand how I got the 42 minutes part. So don't worry, I'm going to be showing you that on the next slide to just clarify how I got the 42 minutes part. Hopefully you understood the rest of the problem. Okay, so we're doing parts B and C continued, but for those of you who didn't understand how I got the minutes, if you understood how I got the high temperature in the hour, that's good. If you didn't understand how I got the minutes, that's also fine. I'll be showing you on this slide. So the answer we got from the last slide is that the vertex is the point 14.706, 75.017. So what we can interpret from this is the fact that the high temperature is 75.017 degrees Fahrenheit, and the time at which this occurs is 2:42 p.m. So as long as you got the temperature and the hour, that's good, but you might still be questioning, how did we get the 2:42 p.m.? So down here, I've written the solution and the clarification. So if you see our x value represents our time, our hours. So we got 14.706, but what does this exactly mean? Most of us read like a 12-hour clock. So after 12 p.m., we see it as 1 p.m. We don't put it down as 13 o'clock, most of us. So we have to convert this back into that 12-hour time reading that we usually do. So in order to do that, you can simply subtract 12, and then you get 2. And this makes sense, 2 p.m. 2 p.m. is 14 hours away from midnight, which was our hour 0. Remember, x equals 0 from that first slide. So we know the hour is 2 o'clock. But we still have this decimal 0.706 that carries over to make it 2.706. So it's not exactly 2 o'clock or 3 o'clock. It's a minute. It's sometime in between. And we want the exact minute, like a near exact minute. So what you can do is you can rewrite 2.706 as 706 over 1,000. So you're pretty much just rewriting this 0.706 as a fraction. So these two values, this quantity is 2.706 and 706 over 1,000. These two are equivalent quantities, so you don't have to worry about them not being equivalent. The reason we wrote it as this is so that we can set up this ratio right here. So 706 over 1,000 equals x over 60. What does this mean? So we're trying to convert this into minutes. And in order to do that, how many minutes are in an hour? 60. So this 706 over 1,000 is some over 60 minutes. So that's what we're trying to do. We're trying to set up a ratio, and we're trying to calculate how does 706 over 1,000 translate to minutes. So that is the question. And in order to do that, 60 is our total amount of minutes. So it's some value over the 60 minutes, which is a total, which is an hour. So that's what we're doing. We're going to be cross-multiplying, so 706 times 60 is 42,360, and then 1,000 times x is just 1,000x. And then to get x by itself, x is our minutes. Remember the minutes that we want. We divide both sides by 1,000, and we get x equals about 42.36. We're going to round this to the nearest whole number because it's just minutes. We only have 2 digits when it comes to minutes. That rounds down to 42. That's how we got the minutes. We put the 2 hours and the 42 minutes together, and therefore the time is 2:42 p.m. I hope that makes sense. You're just going to have to practice more and more with these kinds of problems, and you'll probably get it soon. Okay, we've moved on to part D, which is our final part. Let's get right into the problem. So during this day, this November day in Voorhees, New Jersey, at what times will the temperature reach 68 degrees? So that is the question. Let me repeat it. So during this day, what times during the day? Is there one time during the day, or is there multiple times during the day, or is there not a time during the day that never reaches 68 degrees? Well, can you give me times when the temperature will be 68 degrees possibly? So again, this is a predictive model. We're going to be trying to make a prediction. So let's look at the solution. It says graph the line y equals 68 and find the two intersections. So I'm already telling you it's going to intersect the parabola twice. So why are we doing this? If you remember, something I've taught you before. We've been given a y value and we're trying to make a prediction for the corresponding x value. So we've been given the temperature, trying to make a prediction for the time, and in this case, 2 times during the day. If you think about it, why is it 2 times? Well, the parabola is shaped like this. If we have a linear equation passing through it, it's going to hit the parabola in 2 different points, and I'll show you. Maybe you'll understand it better if I show you on the calculator. So you're graphing the horizontal line, y equals 68, no slope, just trying to find the intersection, and you'll have 2 points, and the x coordinates of those points will be your 2 times. So let's do it on the calculator. I'm going to pull the calculator out. We're going to be going to our y equals, and then hit the down arrow because you don't want to mess with that first y1 because that has your quadratic regression in it. We're going to be typing 68, and then hit graph. And you'll see this horizontal red line, and it goes right through the parabola. It intersects the parabola once on the left side, but also intersects the parabola on the right side. Intersects it twice, meaning there are 2 times during the day when the temperature is 68 degrees. So we got to find those 2 times. How are we going to do that? Well, we need to find where the 2 functions intersect. So in order to do that, we're going to hit second, and then trace to go to calc. Then we are going to hit 5 for intersect. So right now, the cursor is blinking closer to the left point on the parabola. So first, we're going to find the point to the left of the center. So hit enter 3 times, and we get this point, about 11.306. We're going to be interpreting that later, so don't worry about it right now. Next, we are going to be looking at the other point, the right-hand side of the parabola. Don't forget about that. We're going to be repeating the same thing. Second, trace. 5 for intersect. If you see, the cursor is closer to the left-hand point, and if we do enter 3 times, it's going to give us the left-hand point again. So we have to purposely hit the right arrow and go over to the right-hand side of the equation so that it's closer to the right-hand side, the right point. So hit enter 3 times, and then you'll get the other point, which is about 18.105. You can disregard the y value because we always know that it's going to be 68. So don't worry about that. Just jot down the 2 x values, and then we have the first one, 11.306. I rewrote that as 11 and 306 over 1,000. You can do the ratio yourself. I skipped that step because I already explained it on the last slide. 306 over 1,000 equals x over 60, and you find that x is about 17 and a decimal, which rounds up to 18. So we get the minute 18, and 11 is just 11 a.m., 11 hours from midnight. So your first answer would be 11:18 a.m. That's the first time the temperature is 68 degrees. The second coordinate is 18.105. So first you want to subtract, because this is greater than 12, you want to subtract 12 from it, and we find out that this is 6 p.m. because 6 p.m. is 18 hours away from midnight. How are we going to interpret the minutes as well? And in this case, it's 0.105. I rewrote that as 105 over 1,000. You can set up the ratio 105 over 1,000 equals x over 60, and then you'll solve x equals about 6. So then you can write your final answer as 6:06 p.m. That's the second time during the day, which is in the evening, that the temperature will be 68 degrees. So that is how we found the 2 solutions to this question. Okay, that's all I have prepared for us to go over today. I hope you enjoyed the video and going through this really fun practice problem with me using the calculator. If you did like the video, please like, and if you want to see more, subscribe and hit the post notification bell. Drop a comment down below of what you thought, and use our socials to share our video with people who could benefit from it. As I keep saying, we have a website going up soon, and it has so many cool functionalities like notes and self-assessment quizzes, and all of these videos organized into courses for you to just zoom through, especially when you have breaks, summer, vacation, whatever, to refresh or learn new concepts. And I'll be posting all over social media when that comes out, so don't worry that you don't get the memo. You will get the memo. Lastly, if you have any personal or business correspondences that you'd rather not put in the comments, please email us at eCoreAcademy@gmail.com. That's all I have for us today. Please enjoy the rest of your day, and look out for my next Algebra 2 video. Bye! Okay.